Hi everybody, we got a beautiful equation. We expected to find the value of x given that square root of x positive third root of x negative 12 is equal to 0. Now foremost we need to set, or in other words we need to find the domain. Now this equation will hold good for all x only if the value of x lies between 0 and infinity, right? So this should be the domain. So having got that to be the domain, what I wish to do is I would like to simplify this in such a manner that I am in a position to solve it. So with the domain in the mind, let me just make the following substitution. Let x be equal to, say, t raised to the power of 6. And let me take this as 1. Therefore, 1 can be rewritten as square root of t raised to the power of 6 positive third root of x. I'm going to write it as t raised to the power of x raised to the power of 1 over 3 negative 12 is equal to 0. Now this is actually square root, right? So that would give me t raised to the power of 3. This would give me t raised to the power of 2 followed by negative 12 is equal to 0, right? So that's what I've got. I hope you can see this now. Now we will have to perform some manipulation so that we are able to solve this. Now can I write 12 as 8 and 4? Yes, it's possible. So let me do that. So this is t cubed positive t squared negative 8 followed by negative 4 is equal to 0. I'm going to push this 8 towards this t cubed. So this is t cubed negative 8 positive t squared negative 4 is equal to 0. I'm going to write 8 as 2 cubed. So this is t cubed negative 2 cubed positive t squared negative 2 squared is equal to 0. Now I can rewrite t cubed negative 2 cubed as follows: t negative 2 times, this is going to be t squared positive 2 times t positive 2 squared, that's going to be 4. So if you were to multiply t minus 2 with t squared positive 2t positive 4, you will get back t cubed negative 2 cubed. Because all I'm doing is I'm using a cubed negative b cubed formula. So this is nothing but a minus b times a squared positive ab positive b squared. That's a formula I'm using, yeah. Followed by t squared negative 2 squared. That's going to be t negative 2 times t positive 2 is equal to 0. Now from here I can take t minus 2 out. This would give me t squared positive 2t positive 4 positive t positive 2 is equal to 0. This is going to be t negative 2 times t squared added with 2t plus t, that's 3t. 4 positive 2 is going to be 6 is equal to 0. So from here t negative 2 is equal to 0, or t squared positive 3t positive 6 is equal to 0. Now if you were to take the determinant, in other words the discriminant, you will see the discriminant is 3 squared negative 4 times of 6, which is nothing but 9 negative 24, which is going to be less than 0. So that means we are getting a complex roots. In other words, the roots are imaginary here. But the domain is not permitting us to go in that direction. It has to be all real values of x between 0 and infinity. So that means we need to drop this and we need to take only t negative 2 is equal to 0, which means t is equal to 2. But my t is actually x is equal to t power 6, right? So from here, what does this mean? So this would mean my t is going to be 6th root of x, right? So I substitute 6th root of x is equal to 2. So this would mean x raised to the power of 1 over 6 is equal to 2. If I were to raise both the terms to the power of 6, I get x is equal to 2 raised to the power of 6. Now, what is 2 raised to the power of 6? 2 raised to the power of 5 is 32 times 2. That's going to be 64. So this is the solution that satisfies, in other words, this is the value of x that satisfies this equation. Thank you, everybody. Enjoy your night.